Welcome everybody. I'm Ken Baker, interim director of the Integrated Design Lab. I think we're in our about 16th year now. And so as the lab has progressed, this BSUG came along, and that's been quite a few years now actually. And so we have a lot of energy modelers in Idaho now. When I started out at the Energy Division in '86, we did a class on energy modeling. We brought in Charles Ely from California to talk about DO2, and it was like a 3-day class, and it was so difficult to model, but it seemed like it was. You had to know so much. But as things have transpired over the years, and I mean, the energy models out there now I think are really good. The modelers are really good. There's a lot of people locally that know energy modeling. But what we have here today, Jake Dunn, he is an actual alumni of the lab and the University of Idaho, and one of our favorite sons, so to speak, and he's done very well for himself. He works for ZGA out of Portland now, and I know Jake, and I know his presentations because we still use and update some of the presentations here at the lab, Jake. So it's very nice.
That's good to hear.
And yeah, it's very good to hear. So it's a little different group today. I hope some of you continue to come back because we'll continue to have a few more of these sessions this year. But we do have a really good one today with Jake, and appreciate so much you coming back to visit with us and share your information.
It's my pleasure. Thanks for inviting me back.
You're welcome. You got a mic on?
I do. Yep. Sound good? Just turned it to on. Excellent.
I didn't think Idaho Power there. I should have.
Well, it's funny. I ran into Ken. I think it was my first week in Portland, which was like in 2017, and I was just walking downtown. I think I was coming back from a site visit, and just randomly ran into Ken, just on the street in Portland. It was so funny to bump into him there, and then also saw him at the Mass Timber Conference recently in Portland, and we started talking a little bit about BSUG there. But first and foremost, it's fantastic to see that BSUG is still going, and I'm really happy to be able to come back and contribute to this program. I took it over from Ari Junaidi in 2013, 2012 maybe. He sort of started it. It was based off the Portland model, the Building Simulation Energy Forum, and then it was great to kind of take that. I think ran with it for 2 years, then hand it over when leaving. So it's very surreal to be back presenting for it, and it's great to be back in the city in Boise. So in terms of our content for today, I'm really happy to kind of talk about something that I think started with when I was at the lab, right? The sort of interest in data visualization and communicating it specifically to the AEC community, right? I mean, we generate a lot of data at the lab, and it was critical in terms of our engagement with the profession and with the community to be able to actually talk about its insights. And that's a really difficult task in a lot of cases. It's sometimes art, sometimes science, but it's something that from this launch point, it kind of drove my interest, throughout my career, and then finally into some of this IBIPSA committee work to create a community resource to help kind of further that particular mission. So it's called Project StaSIO. It stands for Standard Simulation Inputs and Outputs. It's a website, is sort of the platform that we chose to kind of do this type of engagement. I'm going to talk a little bit about the needs of why we think this is an important resource, the problems that it's trying to solve. I'm going to get into a little bit the website structure, and then I'm going to talk about some of the examples and case studies that have been submitted to it and what we've learned from some of those initial submissions. So that's the general presentation arc. So the first problem that we were hoping to address is this sort of need that we keep hearing, right? This is about the Architecture 2030 Challenge. Quick raise of hands, who's familiar with the excellent AI Commitment 2030 Challenge. So in terms of where we're at, the AI comes out with these fantastic kind of by the numbers reports every year. And it sort of talks about where we're at in terms of all of the firms that have submitted data to the program. So, here's where we're at in I think this is from 2017 is their most recent report. It looks like the average predicted energy savings is around 44%, right? Our target for where we're at in the challenge is 70%. We're just about to go to 80%. So the high level takeaways are always we're doing good, we're getting better throughout the year, but we need to pick it up, right? We need to do more, we need to do more faster, because we really need to start to close these gaps to have the impact that we want to from a industry level, right? And anytime you talk to architects about this, right? We do our own reporting at ZGF, and I've heard a lot of firms talk about their own portfolio data. They're like, oh yeah, what we need to do to fix this is we just need to do more early energy modeling and early energy simulation. That's sort of like the knee-jerk reaction. If we only did more early energy simulation, our buildings would turn out better. And this is more of a hypothesis than a proven theory. I mean, I believe in it, right, in terms of my career, but how you do it is the most important part, right? How you get there, it's not just any early simulation, but it's the right kind with the right kind of framing and the attitude and the integration. So we thought that, hey, we need to develop resources around teaching people how to do this type of early energy performance simulation. Because the bottom line is it's really hard to do, right? I mean, I've dedicated my career to this for over 8 years now, of trying to get architects and engineers to do early simulation in the early parts of the design process. And what I found is that it's very difficult. It takes sort of the right condition and the right attitude and process to do it well. And so here's just an example of something that we typically look at, right? We've got this project. It's a bunch of different forms and masses. So let's analyze this and understand what the difference is in its energy consumption. This is an example taken from the StaSIO website. Pick on StaSIO a lot today, but bottom line is it's a great program if you know how to use it well. And really, it's not any tools issue, right? It's really a framing issue of the way that we're integrating this into the design process. So here we go. We have all of our different building masses. And with StaSIO, you can very quickly get an energy use intensity. You can get kind of a split of your primary load breakdown. And you can also get, what's really nice is sort of this dashboard for what's over or underlit from a daylighting standpoint. So they're running full annual analyses for daylight and giving you sort of a breakdown of what that looks like. But I mean, this is sort of what we're left with, right? 29, 31, 33, 31. It barely moves, right? And all of our takeaways from this is that they're all cooling dominated, and the daylighting amount sort of shifts around a little bit, but this is all not very actionable, right? This doesn't give us a lot of keen insight into which one of these should we actually choose. The differences aren't big enough, right, for us to really gain any insight into this. The questions were too broad, right? We're just trying to understand what's the energy differences between these, and that's not leading us to anything that is empowering, right? A lot of times when something like this would actually be disempowering to architects, right? Because it's saying that the form and the massing isn't really driving energy according to the way that this is starting to be presented. But the real kind of questions and nuance are much more detailed than that. So the kind of takeaways from this is that, our questioning for early performance simulation really needs to be targeted to be effective. And that's going to be a theme that you hear sort of throughout this whole presentation. The other thing would be that, when we're showing EUIs like this is almost attempting to be predictive modeling. And the way that StaSIO operates, at least in this case, is not quite at the level of being rigorous enough to be predictive. So you can only really get kind of relative comparisons from this type of study. And at that point, do you really need to run a full simulation model? This is pretty much tracking with skin to volume ratio. And honestly, intuition probably gives you a sense of like which one of these is going to perform better. Same thing with daylight, right? If you're not doing blind control or some of these more detailed modelings, then you can sort of understand what that impact is going to be without having to run simulation. So the other takeaway is that if the problem isn't complicated enough or complex enough, then simulation isn't always a good fit to investigate that problem. So questions need to be targeted. The problems need to be more complicated than this in some cases, and the framing has to be there. So this is something that we're going to return to. And here's another example that kind of always drives me crazy. Another StaSIO example, not picking on them, but they have some good case studies on their website. So in this case, you have an architect looking at multiple different types of facades, sort of a typical approach. In this case, it's sort of window to wall ratio with a different type of detail that kind of projects outward. And what you generally start to see from this that you can get out of the program are a bunch of bar charts that talk about the trade-off between, cooling energy is blue, solar load is red, daylight is orange, and these are kind of baseline and two different glazing types. And what it's telling you is you get sort of a marginal reduction in solar gain when you go down in window-wall ratio, pretty obvious. That equates to a negligible difference in cooling load, and all the daylighting is the same. This doesn't tell you anything, right, that you wouldn't know just from sort of looking at this. They add sort of shading layers on top of this, and you start to see this is the overall energy start to drop. But if you look at the axis, it's truncated. So when we talk about good graphic clarity, that's one of the pitfalls. And it really is only about a 2% energy difference, right, adding shading to this. So once again, this isn't really being driven by any particular question around like HVAC system selection, target loads, comforts, but it's really just let's see what the energy differences are. And the result is something that, once again, is not significant enough to really drive decision making, and it's generally obvious just by looking at the project. And it takes sort of a lot of training and time to be able to set up these simulations. So this actually is not doing us any favors, right? This level of study and this level of analysis. So how do we get sort of beyond this is one of the questions, both in terms of setting up early conceptual simulations that drive design, and then also kind of engaging designers and engineers and early stakeholders around how we present that data and form a conversation around it. This is another example. This is actually out of Autodesk's Insight 360 tool. It said it's not the tool that's the issue. In this case, it's just the question and the problem. Do all of this, and then this is the takeaway. Solar radiation average analysis at 9 a.m. and 3 p.m. Radiation values vary between the bottom level and the top. It's great, didn't necessarily need to run a simulation to do that. What insights is this driving? What's the role of context in this case? How does that affect programming? There are much better questions that this can start to solve if we're just asking the right types of questions in that case. So problem number 2, there aren't a lot of good examples out there of how early simulation really leads to a better building in the end, right? There's ultimately a disconnect between even this type of modeling and the kind of compliance model at the end when we do a full-blown rigorous analysis. And what's the relationship between those two? It's not a very direct line in that respect. Okay, so problem number 3 that we're looking to solve is this communication gap between simulators and designers, right? This is one of my charts, so I get to pick on myself a little bit too. Look at all the bar charts, right? Who is gonna look at this and really start to engage with it when I have 2 seconds with a design principal trying to talk about their facade design, right? This is not doing me any services, although there's some good parts about this. Fundamentally, it's too dense, it's too complicated. There's nothing about geometry or impact implicit within the graphic. So you show this to someone and their brain just sort of turns off, right? I'm trying to represent, a multitude of different variables that are geometrically based in a table of all things, right? It's color coded, yes, but for the most part, this is really hard to track exactly what we're talking about. We have a threshold identified and, some different cases that actually work, but still this is fundamentally just a dressed up bar chart, right? And how do we get beyond this as well? Because we have sort of things like this, we have, full-blown energy modeling reports, which also, aren't necessarily giving us the insights that we need, especially early in design, right? We should even really be getting, full-blown energy modeling reports for that. And then also, I just got an example sent to me earlier today. We're looking at Okalux as a product, which is sort of an integrated louver system within an insulated pane. And they can do lots of really good optimization analysis to say that we can block, direct sun anytime you need it. So just tell us where you want direct sun and we'll give you an egg crate design that fits in a glass that will block it. And I was like, this is great. So they sent us a report to our designers and it's like a 30-page a table with a bunch of orthographic solar projections and all these intersecting lines. I could barely read it, right? Much less our designers trying to incorporate that into design. So this is a fundamental problem that you see sort of at every level of our disciplines and industry, at every phase of design, is how do we actually communicate data that's insightful and actionable and easy to understand for non-technical folks and designers, right? Because, if we really are talking about integrated design, whether we're an engineer, working with architecture firm or a design team, whether we're a third-party consultant, whether you're internally an architect working with the design team, we have to be able to talk to designers about what this data means. So problem number 4 that we're trying to solve with Project StaSIO is the fact that it's hard to learn from each other. BSUG is a great example of a kind of a community that we've built in Boise, people coming together and trying to share sort of technical solutions and simulation processes and workflows. Doesn't always exist everywhere, right? And there's a lot of really good resources around how to do simulation. This is Unmet Hours. This is a fantastic forum where, you know, they have all of the different energy simulation programs on there. Experts, you know, peruse the forums, and you can, you know, ask questions about technical problems that you're experiencing. There's not something that exists like this for, you know, how effective was the study? What did you learn from the study? How did this impact design? That's what we need, right? Or that's what we needed. And Sapphira has a really good kind of case study page. A lot of the kind of software providers do. But like I said, you go through those Sapphira examples, and a lot of those studies you just are left wanting at the end, right? They're not really good examples of how early performance simulation helped drive design and lead to a better product. And the other thing too is, so at ZGF, we're a big enough firm to where there are multiple people doing simulation. We have sort of our own internal user groups and a lot of different experts. If you're in a firm of about 30 and you're the only one sort of doing modeling and you're trying to do this, it can be really hard to share information with folks across firms because those channels aren't always set up. A lot of times people hold their kind of industry secrets and their processes pretty close to their chest. So there's no sort of online community around that. There's no way to kind of give it across different firms unless you have very specific cases like with BSUG. So we're hoping to also develop something that allowed there to be that simulation community to kind of cultivate. Okay, so those are the 4 major problems that we're trying to solve, and now we can get into our specific approach in terms of how we are trying to solve them. So Project StaSIO is the name of the website. Can't remember how we came up with that, but essentially just trying to slam together an acronym. Sounds like some Italian soap opera in my mind, but it's stuck around. But fundamentally what this is a crowdsourced graphics and case study library. That's what it is at its heart. And this is the team that made it. And we're really proud of the team because we're all interdisciplinary, right? That's sort of the way that it should have been. And so this was part of the IBIPSA USA Architectural Simulation Committee. I think I got that right. So I'm part of this subcommittee, and we've all, you know, got together, and our task is in general trying to create resources that support the simulation community. So we started thinking about it this way. So we've got Supriya from PNL. She's a researcher at heart, right? She's a lab type. Alejandra is from Thornton Tomasetti, and she is like a CFD technical wizard, right, around CFD simulation. Chell Anderson literally wrote the book on design simulation graphics for architects, right? His book might be around here. I bought it when it came out back in 2014. Works at LMN. He's the director of building simulation performance over there. Michael, so he represents EDSL and TAS, so he's a software rep. There's me. And then we actually have been recruiting more folks to work on the committees because we're kind of launching into our second competition. We've been needing more committee members to kind of get involved and help us out because we're all getting burnt out working on this. So engineers, architects, simulation specialists, researchers, software manufacturers, it's a good team to kind of tackle this problem. And so our website is evolving, which is great because I built this Squarespace website about a year ago, and we kind of used that to form a proof of concept to kind of house all this information. How do we do crowdsourcing for this? How do we like get it in a format that's not terrible? And then at the end of that year, we had a proof of concept, and we were able to apply for DOE funding to give us a website developer to kind of take it to that next level. So that actually just launched this morning. It was not up yesterday. I was sweating bullets. But I can show you guys a little bit of it today, but it's pretty raw, and we have to work out some of the kinks because now it's live and we can actually see it. But it's been great because we were limited by some of the kind of filtering and functional and reviewing capabilities of the Squarespace template. Now we have something that's much more feature rich, but it was great to kind of go through that process, get funding, and actually have a professional work on this website for us. So the kind of early thrust of the committee, and actually I guess it was the entire origin story, is that we were tasked with trying to figure out a way to support the ASHRAE 209 standard. Somebody familiar with ASHRAE 209? I know Tim probably is, a couple folks. So this is relatively new, but it's ASHRAE's version of trying to have a standardized process for integrating early energy simulation for design, right? So this is a framework for if you want to do early simulation modeling, follow these steps, and it's a good process. So they talk about like energy benchmarking, climate analysis, and then there's all these modeling cycles, and you have to do a certain amount of these at a certain time in the project to comply with the particular standard, excuse me, depending upon what you learned in your sort of early investigative studies. So for us, we were focusing on sort of the top 3: simple box modeling, conceptual design modeling, load reduction modeling, and trying to say, okay, well, there's this standard. They talk about doing this, but there's not a lot of good examples out there for what is, simple box modeling and what types of questions can that answer, and, give us some examples. So if we're trying to evaluate whether we're going to use this standard, we want to sort of know what it can do, right? We want to have some basic understanding of the process and what problems it can solve. So, we needed to make sure in whatever we did that we were providing resources around that and examples for ASHRAE 209. And then, we are slowly trying to, fill in all of these other different cycles and figure out examples and case studies around those as well. So everything from, value engineering, like trade-off optimization analysis is a great application for simulation, all the way down to what does a post-occupancy energy comparison look like when you're using simulation and comparing it to post-occupancy data, M&V data that you're getting from a building automation system. I mean, there's fantastic examples around that we hope to populate at some point with the website. So this is the structure of the website, or what we were trying to do, right? So this is the sort of topology that we were trying to create in terms of, we have a simulation category, daylighting. We know that there are subcategories to daylighting. We broke them into 2 general categories: functional daylight simulation and visual comfort simulation. Seems to be a natural split. We were interested in trying to figure out what are the questions that you can answer or explore according to those different categories. And then once we identify a question, we wanted to figure out and provide some roadmap for here's the kind of key inputs that you need for doing something like spatial daylight autonomy with occupant blind control. Here's the outputs that you can get when the world is SDA, ASE, all the different metrics, and just kind of lay those out, which is sort of a QA/QC guide to like that. That's sort of in the future scope, although we're touching on a little bit of it. What we're doing first is, based upon that question, is we're really interested in trying to gather graphic examples and case studies to where once we get an example, we can talk about what the goals were, insights, and tips and pitfalls for doing that kind of simulation. And part of that was starting now to categorize and catalog what were the key inputs and outputs for that. So our goal was to take all of the things you can do with simulation, populate it, and then start to aggregate examples around that. And part of this, there's really, based upon that structure, there's 2 fundamental parts of the website. The first part is this questions menu, which actually took this from Better Bricks document that came out, I think, in 2012 when I was here at the lab. And it was great because it was their own guide for like integrating early simulation into the design process, and they had it by phase and sort of like all the things you can think about, and they had bullet questions at the end, which were think about these questions when you're doing design during this phase. And I was like, how great is that to have sort of a menu of questions per phase that you can start to take to your project manager and say, hey, I think we should do this. So connecting it back to my time at the lab, right? We created like that on steroids for this particular project. We kind of went through everything from those daylight categories to whole building analyses and try to list out what were all the things that we had studied as a group that we can start to list as, hey, this is something that you can look at, right? So, how much more energy will my building use if occupant density or use schedules vary from initial assumptions, right? Very key question when you're talking about net zero design or load matching with PV. all the way to, what are my energy end uses range from highest to lowest, which is a great question that you can answer with whole building simulation. So these link to the examples and case studies, right? So once you find this out, you can click on this and it will take you to all of the graphic examples of someone trying to answer that question so you can learn from it. We primarily wanted to have this be a tool for project managers, right, that don't know technical simulation, and they can go here and understand the value that it can provide to their project, right? Because these are just design investigation questions. And then we also wanted this to be a resource for the simulationist who says, okay, well, I know that solar control is going to be really important for my building type in this climate. So what are the questions that I can answer? I could probably rattle off 5, but we've got like 20 of them on the website. So you might learn that you can do something that you didn't have in your purview, right? So it's a roadmap for someone that knows simulation to kind of get inspired and know what those examples are. And then it's also a menu for kind of value propositions for PMs that aren't technical, right? So this is something that's sort of constantly in flux, but we have, tons of questions that we're populating kind of every week up here. And as we get more submissions, they'll automatically link to this list, so it will get populated by the content that's on the website too. That's one of the goals. So the second part of the website is the graphics library. There's also a case studies library. And this is where we sort of house all of the submissions that we've gotten from, the internet, from our engagement with the IBIPSA, users, AIA, all of our kind of promotion, like with what I'm doing here. And, the key thing here is that these are available, and then we have some type of filtering mechanism, like an Amazon shopping list, where you can say, I'm doing ASHRAE 209, I really need to understand load modeling, so I can click this and this will automatically shuffle and show you all of the ASHRAE 209 cycle 2 load reduction modeling examples, so you can learn, get inspired, and start to understand that. So we have it broken down by cycle, by the different categories, also by tools. So if you're using Honeybee for energy analysis or want to know what people have done that for, you can filter for that and then it'll reshuffle. Inputs and outputs. So let's say you want to look at annual sunlight exposure as a metric. What are the different ways that you can deal with that? You'll be able to filter for that and everything will come up that have tagged ASE as one of the outputs for their submissions. So that's sort of the guts of how we intended the website to work. We're able to get pretty far there with sort of the Squarespace site, but the functionality is much better on the new site in terms of its navigation and like the checkboxes you can click on and off to kind of look at different filters. So to do this, we try to make the contribution process as simple as possible. So on the website, there's a contribute page. You have the option to submit a single graphic or a case study. Case studies are a little bit more involved. The graphics probably take about 30 minutes if you sort of know what you're going to write. Case studies probably take closer to an hour, depending upon how in-depth you get. But what's nice is that you click on this and it takes you to an online form that you just populate as you go through. And then you submit that at the end of the process, and then it goes into a form where people can review it and then post it online. So with the new website, I believe you have to log in first, but I think I have a step-by-step on how to submit after one of the examples, which is this guy. So this was really important though, because if it really was about being a crowdsourced resource, we had to think about all the mechanics of crowdsourcing content, which turned out to be way more complicated than I ever thought it would be. So I did want to talk about what questions are we asking, right, when people submit content, because that really becomes the key, right? If we want this to not be like the Sapphire site and where we're really trying to extract how did this impact design, we have to ask that question. So I just wanted to do an example. This is another one of my graphics that's on the site of what that process is. So the very first question is you have to name your graphic or case study in the form of a question using the following format. What is the impact of X input on X output? And we found that that's like a good way to organize those questions so we can have them in our questions menu. And it's always like insightful, right? Because you're saying you're trying to analyze this kind of geometry or schedule or process on a particular outcome. So in this case, it is, what is the impact of different blind control strategies on illuminance over the course of an average day. That's the name of the particular graphic. So the next question is, what are we looking at? And this is a chance for, I think they're like 250 word maximums in each one of the different sections. I'm just going to summarize those for this graphic. But in this case, since this is a fairly complicated graphic, that allows us to say in the field, well, this is looking at two different blind control strategies. One are MECO shades, and the other are blind slats, essentially, both automated. They're compared to a baseline condition without any solar control. And it's shown for a typical day in October. So there's a key for what the sky condition is on the bottom. Everything's in lux, so it's illuminance, single point in time, hourly illuminance. There's a key up on top that sort of shows when the blinds are being triggered based upon those different sky conditions. And then we show sort of in the corner some of the key takeaways with like the actual geometry of the space and its particular context, right? So just the bare basics of what exactly are we looking at. So the next question is, how did you make the graphic, right? And I think that's a really key question too, because there are so many different ways and workflows to do it that it's really interesting to kind of see what people are submitting and figure out how much of it was post-processed, how much of it was done within the program, so on and so forth. And the kind of key thing about this particular graphic is, thinking back to the old days, right? You can imagine doing this in like Ecotech and Radiance and having 30 different image thumbnails that you put into like an InDesign file. Just makes your head explode a little bit. But since the analysis in this case was done in Grasshopper, a lot of the graphic manipulation can also be done in Grasshopper, which is a plugin for Rhino. It's a parametric kind of visual programming interface. And what's nice is that since we're running each one of these for a certain amount of hours throughout the day, all these files get automatically stored into a folder, and then the kind of graphic component of the tool allows you to kind of harvest the image files out of that folder and then translate them according to a script to where these all get automatically placed in Rhino. And then you just render that screenshot and then plug it into InDesign. So all of this is one image that gets automated and comes out of Rhino. It allowed us to do so many different iterations so much quicker because of just the graphic workflow of how to produce a sort of complicated matrix of time series data. So that was one way, and then everything else is post-processed, right? All of these labels and stuff are in InDesign. This was all in InDesign. These labels come directly out of the program, so those were automated, but there's always some level of post-processing that goes on. So then the next question is, what specific investigation questions led to the production of this graphic? So going sort of back to the title around, we're really interested in the difference between these two different blind conditions. That's primarily was driving the entire thrust of the study. There were some implicit kind of workflow questions of like, how do we simulate this properly between MECO shades and blinds, which have to be kind of angle optimized. So we did that all within the script as well. So there were some more complicated simulation questions that we were investigating as well. But fundamentally, blinds versus shades, and specifically how much of a difference, because we know that blinds are going to be better because they redirect light, but we want to know how much, because we also know that blinds are going to be more expensive. So we had to advocate to the client the value of them through these types of studies and the quantification of what is that particular difference. Didn't mention it before, but this is a makerspace at part of a lab building on campus in California, essentially. So sort of a small jewel box that they wanted to be a feature of the campus. They wanted to be all glass, but we also know that for makerspace, the kind of comfort requirements and the visual acuity requirements are high, so those were automatically in conflict, which is why we looked at automated shading. And that's sort of getting to this question: how did this graphic fit into the larger design process, and what did you learn from producing this graphic? So, because we had this fundamental conflict between wanting a glass box and needing acute visual control, we didn't want there to be, okay, well, the sun's going to be on this facade so often, the blinds are going to be drawn a lot, right? That's what this is starting to tell us. So we want to make sure that when the blinds are drawn in that condition, that it doesn't kill the quality of the space. Because if it's a MECO shade, it's just kind of a reduction of daylight coming in, versus if it's a blinds, it's redirecting that and actually having a better impact on the space. So what we learned at a high level takeaway is that depending upon kind of what hour you're looking at between baseline condition with Meco shades with the blinds, you can just tell from a color standpoint that there's a big difference here. You could read this, you could tell that it's roughly 2 to 3 times more daylight in the space with these automated blinds on average across this. So that was sort of the highest level takeaway that we wanted to look at. But that sort of also goes to the next question. What is successful about this graphic in the way that it communicates information? And what we wrote in the form is that there's a high level takeaway. You don't have to get into all this detail, right? You could just look here and that's your highest level takeaway. But the further you look into this, the more detail you can extract out of it, including things like spatial data. So this is a little misleading. There's a section down below that doesn't have any blind control. The blinds stop, I think, 11 feet above the ground, and there's an overhang. The simulations all take this into account, but I didn't get it into the key graphic. But what's interesting about that is that you can see, even with the blind condition, that you get like a little bit of a hot spot still in the evening, right? So even with these automated blinds with the better daylight, you still have sort of a hot spot from a glare perspective that needs to impact programming. So when you're thinking about the layout of this makerspace, you want to make sure that those high visual acuity tasks aren't in that particular piece because of that low angle sun and the overhang, and the blind stoppage does not solve that, right? So you can like even dive into what does this red dot mean and get some insights out of it that way. So that was sort of one reason why we liked the way that this communicated that particular graphic. I think also just showing the blind control up here in this case, because you're really looking at 2, there's a third face as well too that actually doesn't show up on there, of when those blinds are deployed is key to understanding the graphic. So, that was sort of answering that question. And then the last question is, what would you have done differently if you had more time? So, I mentioned it before, these titles could be bigger, would be nice. And then also the fact that I didn't include that region at the bottom that's always clear makes it a bit confusing if you're trying to draw, like, why is this here if the blind control is perfect? So there's a couple of things that, is good to ask about, because there's always tweaks that you wish you could do, and we want to learn those sort of best, case studies and those pitfalls for these different types of graphics. So, that was like 5 fairly simple questions, and the level of detail of the answer, can vary, and you'll see that across the website. But that's sort of an example of the level of information that we're asking, and really trying to tie it back to that investigation process and the design process. Okay, so as I mentioned, the submission process is fairly straightforward with the new website. You've got to create an account, you submit. We really spent a lot of time making the online review process a lot easier with kind of iteration 1. We had like a Google spreadsheet that we would like email you, and you'd have to modify it, and then you would email it back, and then we would go back and forth that way. It was just ridiculous, right? So now everything is more like a journal paper kind of format, to where everything is handled within the website, and you can log in and sort of see my comments on your submission, saying like, oh, I think this legend needs to be a little bit bigger. Oh, I think this could be a little bit clearer. Hey, I modified this typo, is that okay? And so the back and forth is a lot more seamless now, which we're really excited about, especially because we get 50, 100 submissions for our next competition. It needs to be streamlined. So after we do that, then we post it and it shows up on the website. What was really interesting is that in 2018, our competition recap, we started this, we got about 20 different submissions just from us engaging folks. Then we were like, hey, we should probably do a competition and really use that as a catalyst for getting these particular submissions. So we launched a competition. Winners were announced at the SimBuild conference in Chicago last year in the fall. Launched the competition in the summer. Results are in the fall. And it was great because we got 40 different graphics. We got 12 different case studies. Recognize this one came from the lab. And we set up this whole competition structure, which I think has been really great for the website to actually get those submissions. And we set them up sort of like the AIA system, to where, we couldn't really rank them because we're getting very different types of like graphics and simulations. So we really looked at honor awards and honorable mentions, right? So these are the 3 graphics that got honor awards, and I'll talk a little bit about those next. These are the 2 case studies that got honor awards, and this actually won the People's Choice Award. Sankey diagrams, who doesn't love Sankey diagrams, right? So it was great because it did its job. It was so successful that we're doing it again, right? We've launched our 2nd competition. All this material just went out earlier this week. So our submission deadline, if folks are interested, is 7/15, and then similarly, winners will be announced at the next sim build. If you get an honor award, I believe you get invited out to present during one of those particular sessions. We did it last year, it was a lot of fun. But we've got a page for details of what that framework for judging is, and we just started to launch this. So if you do submit, there'll be a checkbox at the very beginning that says, do you want this to be part of the competition? Yes, no, maybe. And then you'll move forward in doing the actual form filling. So, okay, so that was a lot of the details. I do want to talk about what we learned from some of the particular submissions from 2018. Go and just do a quick time check. So this was one of the graphics honorable mentions, and what was really great about this is a pretty simple analysis to do, right? This is a butterfly shadow diagram. This is for September 21st, and they took every shadow at every hour, overlaid them on top of each other, and you get sort of this heat map of where light is and where dark is from a direct sun standpoint. So they took this to the next level in Grasshopper, and you can read about how they did that on the website, and kind of did a 2-tone color to where the AM shadows are red and the PM shadows are purple, blue on the screen, purple up here. And that was really great because they're designing for this community park. You can see the footprint. And because of the programming, the park had a very specific occupation during the morning, a very specific occupation in the afternoon. So they really wanted to understand the difference in shadow patterns between those 2 different time frames. So this kind of allows you to do that at a glance. It also provided key insights into plant programming for the landscape in terms of having a low, medium, high exposure to sun. So based upon this condition and also these other solstice and equinox conditions, they could actually give that information to the landscape designer to help their plant palette selection. So, pretty simple, but there was a lot of insights that came out of that. And they're kind of, doing one of my tips always with graphics is that there needs to be sort of a spatial component, right? So you understand impact of geometry on performance, whatever that is, and then a quantified component so you have a benchmark to study if you're doing variations and iterations. So they just roll up in terms of percentage of the site that never gets shade in the AM versus the PM as another sort of metric to evaluate things by. So this one was great. And I remember reading in their submissions is that, when they were asked what was the most successful thing about the graphic, and they said that people actually wanted to talk about it. So they attribute that to it being visually interesting. So when they took this to their charrettes with the clients and other stakeholders, they said it generated a lot of discussion around that, which is a fantastic outcome, all because of how visually interesting it is. So this is a climate clock, is the kind of name of the graphic. And the judges really loved this one. They thought it could show up in any one of the Tufte books, right, that talk about kind of infographics and graphic communication. But one of the key takeaways here is that, one thing that drives me crazy is when you see climate, and I call it inventory, when you just have data up there that here's what the climate is. Here's all the temperature plots, it's a crazy line, changes on its axis across the course of the year without deriving any insights from that. So when you move from just showing data to deriving insights, that's what we're calling climate analysis, right? And this is a really good example of both of those, because you got this climate clock, which sort of puts all of these different variables and data points, temporally across the year. The kind of overlapping is interesting to kind of start to derive certain types of interactions. But, they've also kind of given you some key high-level insights based upon this particular data. So like sky cover, sky is mostly overcast in the summer. That's this kind of gray guy gets bigger and then goes away. I mean, that could be important for any number of different things. Passive solar, like this is the ideal climate for passive solar, cloudy in the summer, sunny in the wintertime, so on and so forth. Solar energy, they did sort of a roll-up of what the annual availability is and determined that it's deficient. Not sure kind of what they're using to qualify that, but the fact that they're making a stake and kind of talking about what that means. They had this whole section on comfort, which looks at percentage of time comfortable versus heat and cold stress, and they're giving you, similar to what our psychrometric charts give us in terms of percentage of the year that's comfortable, but it gives you some additional data on when it's too hot, when it's too cold. A lot of that's based upon direct sun and not direct sun. And then, of course, the wind data is pretty clear that most things are coming from the east during most of the year. So that's a key takeaway. But I mean, just so much you can like really dive into this, right? We wanted to get this printed on shirts for the competition, but didn't end up working out. But similarly, this became a mascot for the project is one thing that the presenter, he presented at SimBuild with us. And he said that, this really was the symbol for what the project became down the road, because they really wanted to be sustainable and climate responsive. So this, of course, was really good information to have. And it was ever present throughout the whole design process because of how visually interesting it was. Sir, this also is Grasshopper. Yep. And the crazy thing about this is, in theory, the person that made this could share their script, and you just plug in an EPW file, it would automatically generate this. That's one of the beauties of using Grasshopper as a workflow, is that you can templatize a lot of these analyses and just plug and play your different climates. I don't think AACOM would let him do that, but that's something that if we were really being forthright about this kind of sharing research attitude, then that'd be great. But yes, that was the program they were using. And then we also wanted to say, it's not all about Grasshopper. Excel is okay, and sometimes it's actually great too. Part of the judging criteria was just how simple and clear was the graphic, right? So if it's just a very clear, bar chart that really communicates something, then we score that highly in our overall kind of framework and criteria. And this one is a little bit more intense than just a singular Excel graphic, but it was really clever that it's basically an Excel line graph that uses 3 dimensions to kind of overlay these different conditions. So this is about how microgrids and battery storage can optimize greenhouse gas emissions based upon variable greenhouse gas impact factors over the course of a day. So, they're saying that you've got energy use and CO2 across the day here. When you've got solar, it kind of gives you credit during a certain part of the day, so have energy at night. What's really cool about this is it rolls up energy and carbon in this other dimension. And they say if you actually stagger that with battery storage, you can provide the electricity at different times. And this actually leads to a decrease in carbon energy based upon the time that you're providing energy with your batteries, right? Or the microgrid in this case. So pretty clever, and it's hard to see, but they're overlapping all of these as the graph goes. So you can actually see very quickly how this relates to the previous cases. So a lot of really good, sound graphic fundamentals going on this. So it got an honor award and primarily used Excel for it, which is great. Okay, so I think we're doing pretty good on time. It's 12:54. So I wanted to sort of return, as we talk about our case studies, to the fundamental question that we had at the beginning, which is what is the nature of early energy modeling, early performance simulation? I gave you a lot of reasons of like how it can be bad, but I wanted to leave you with examples of how it can be good, which is fundamentally what Project StaSIO is about, inspiring people to understand the value of early energy simulation and how to communicate it. So these are sort of the 6 tenets. Number 1, what we're seeing for this to be effective is that we have to do more earlier, faster, right? If we want to be truly impactful in design, design moves at such a rapid organic rate in most firms that, it's really hard to touch bases within that feedback loop. Starts to become one of the most important things in the project or in your sort of integration with the process. And this is sort of related to number 3, which is because it's early and the designers don't know exactly what they're doing, you have to simulate a range of possibilities. You can't just simulate one thing. You have to simulate the parameter space that their design might be. And the whole goal is to give them sort of design bumpers, performance bumpers, to say that, your shading device can be this shape within this kind of envelope, and you're going to still meet your goals. And that's a really good way to help influence design without being overly, deterministic. And then, we mentioned complexity is key. You have to have a problem that requires simulation for it to be impactful. If it's so simple to where it's just like, will an atrium increase daylight performance? The answer is yes. Don't run a simulation, right? The answer is just yes. But if you're trying to say, well, within that atrium, we have a series of different informal spaces and then office blocks on the outside. How deep does that get? And can we optimize the shape of that atrium to like block direct sun, but allow for, a certain SDA? Now that starts to get targeted enough to where you should be running simulations to help solve that. So the complexity is key, and I've got an example of that too, if we can get to it. So with all of this, we're seeing a trend of moving towards more parametric grasshopper-based simulation, right? Running hundreds, if not thousands of options to start to address all of these different attitudes about modeling. So when we're doing that, the key becomes now we must navigate these large data sets in ways that are insightful. So I've got sort of an example of that, an interactive way to do that, and a static way to do that, and hopefully I'll be able to get through that here in our last couple minutes. So this is a project that I'm working on. It's just a large, we'll just call a large bay volume. And essentially, we're looking at daylighting. And we locked in two of these variables. The facade, we kept the same. The sort of interior clear story, we kept the same. This is about 400 feet. This is about 1,000 feet. And we really were interested in to hit a 75%, illuminance target for cloudy Portland conditions. How tall did this monitor need to be, and how many skylights did we need in this kind of fabric part? So what's the right skylight to floor area ratio for this patch, and then what's the right height for that particular patch? And so just that question alone, I can't really do it through intuition, right? I might be able to say you could do it with just this at a certain height or just this amount of skylights, but the combination of the two, intuition starts to break down. So there's a new tool out there called Design Explorer, which is free, online, and it's basically a CSV viewer that uses images and three-dimensional files to kind of give you additional information. So I would recommend checking this out if you have time, but I'll give you guys a quick preview of how it particularly works. So, all right, stand by. Okay, so parallel coordinate plot. Has anybody seen one of these before? Tim, I know you have a couple of folks. Basically, this is just a way to show that given a certain set of inputs, these black guys, you get a certain set of outputs, these blue guys up here. So each line is its own simulation. So, this is the bay height. So given this particular bay height and this particular skylight to floor area ratio, you get a certain percentage of the floor area that's daylit, and you get a certain skylight to floor area ratio, and this is a certain annual sun exposure. Let me turn that one off, actually. There we go. So, we're tracking daylight performance and area or cost, essentially. So what's nice about this is if my goal is 75 for this particular metric, I can be like, okay, well, let's just filter all the cases out of which ones don't meet that particular goal. So now we're down to 8, 9 different versions. So that's one way this is great, because you can filter for these different outputs or your different performance outcomes. But let's start sort of over here, because if I say that we don't have any skylights except for that seam and the perimeter, then it says, sorry, the kind of lag here, and there we go. Number's a little bit small, but this is saying that it's at a 55% daylit. We're trying to get to 75. So I can say that right away we need something in terms of skylights and clear stories or these monitors. So if I go up to a 5-foot tall monitor, then it gives me an increase in performance from 55 to 62. So good, but we're not at our 75% goal yet. So I can kind of keep going up, and I can go to a 10-foot tall clear story. And it shows that now we're getting about 74. So if we were just doing clear story, this is a parameter I would write down, give the design team 10 feet is about the right height that you should be thinking about. And I can do the same thing for the skylight to floor area ratio. So I can say that, okay, well, if you have 5% skylight to floor area in those patches that we were showing, then you get, essentially, you go from 55 to 56. So they're not doing anything. So that's a key takeaway right there. 5% is not big enough. We go up to 10%, then you know, it's 60%. So doing better, but we're still not at our 75. So you can keep going up and up and up. And we're finding that, you know, a 20% skylight to floor area ratio gets you 75, essentially. So a 20% skylight to floor area ratio or a 10-foot tall monitor will both meet your goals. Those are two good key takeaways. But what if you wanted to combine them? You can reset this, and then you can start to, okay, so let's say if I do a 5-foot tall clear story and a 10% skylight to floor area ratio, it gives us 68%. So not quite 75, but pretty close, within striking distance. So, you know, we actually recommended this as a potential option if you wanted to combine them. And what's nice about this, though, is that not only can you navigate the data, you can start to also look here and understand the kind of spatial distribution. So we have a lot of goals around like the rhythm of light in the space as you sort of move through it. There's also this kind of 3D viewer that gives you sort of a sense of what those look like, you know, so the geometry sort of changes around in case you need a visual representation. And that's a really great way to kind of communicate some of that information as well. And you can also include some of the grid data into this as well. So this is a really kind of comprehensive tool that allows you kind of the ability to interact with these data sets. And this is only a single variable. When you do multiple variables and you want to look at highest daylight, but lowest cost and lowest, you know, peak solar load, you can start to do that and start to understand, you know, what ranges of parameters or geometries can get you there. So this is a really good way to do that. So I just wanted to leave you, I know we're right at the end, so I'll wrap this up, is that takes interaction, though, to do. So there's still a need to kind of solidify that into a singular graphic to communicate all of that information. So a lot of what we saw, and this is the new website, take some cleaning up, filter for case studies, is that you know, teams are thinking about ways to actually communicate that singularly. So this is an example here, this one, an honor award as well, to where this team is thinking about, well, how do I talk about, this is like very similar to that first Sapphira example. I've got all these parameters that I'm changing, window width, window location, height, overhangs, fins. Scroll down. Oh, this is squish. We got to work out some of these graphics. Then they're looking at, okay, well, here's all those variables. Here's the outputs that we're looking at. Here's sort of our framework for analysis. And then they get into, well, how do I actually show that in a singular bit? They're highlighting sort of two different streams. So these are two different examples, and they kind of key them to this matrix. So they're giving you that kind of visual connection. They're telling you what their inputs are, what their outputs are, and they're doing a comparative analysis between two with that same type of parallel coordinate plot. There's a million different ways to do this, and we've got about 5 different examples on the website that you can look at and start to understand what are the strengths and weaknesses around using this type of format for these large data sets. So I would encourage you to check out the website. You can read all about what in the hell were they doing with this case study in terms of the design analysis, how they did the graphic, how they set it up, and the ultimate insights they gained for the designer. So that's what the website's about. If you're interested, like I said, competition is open for 2019. So those will be open through mid-July if you're interested in contributing. So yes, with that, I'll go ahead and open up for questions, and I'll stick around too a little bit afterwards if people need to take off. But thanks for having me, and it was great to come and talk about this kind of stuff to y'all. So thank you.
Thank you, Jake.
Yeah.
Very good. Does anyone have a question for Jake at this point? Well, he's going to hang around like he said. We are going to do a little raffle right now and give away some gifts, and then you can go. I do want to, I neglected to thank Idaho Power. Idaho Power sponsors all of these. In fact, a lot of what we do at the Integrated Design Lab here is sponsored by Idaho Power, so we really do appreciate them. You should look at their